Alrighty, everyone who is present, thank you for being here. This is our first event of WiGL online. I'm Jay. If we haven't met before, I'm one of the co-presidents of the LSO, which is the student org that puts on WiGL every year. And this workshop is getting started with LaTeX, run by Daniel Quigley of University of Wisconsin-Milwaukee. So yeah, I'll turn it over to Daniel. Take it away.
Hello, everyone. Thank you, Jay, for letting me host this workshop. This is the second time that I've given a LaTeX workshop here, and both times have been for linguists as an audience. But I would like to ask, I have the main workshop here, which is just LaTeX in general. And then I have a follow-up that I will be making available which has specific tools for linguistics. I'm going to have this on the side in case people want to reference this later. But the main content of this is simply just generally getting started with LaTeX. LaTeX, for those of you who are maybe unfamiliar, is it's a typesetting software, and it's maybe not the gentlest of learning curves. And so the idea here is simply to just get you started. And then for those of you that may know a little bit more about LaTeX already or are curious about what it looks like for linguistics, I do have additional slides that can go over those. But for today, what I do want to go over is simply just getting started and having a place to orient yourselves relative to this typesetting software. All right, so let us begin. So we're going to walk through a general introduction, some what are called MWEs, or minimum working examples. We're going to go through an example of Hello World, and then I'm going to walk through some of the usual components that show up in LaTeX documents, and then we'll conclude. Now, all these slides and some examples that we'll work through will be made available to you to reference at a later time. I will upload them to my GitHub after this weekend, after the conclusion of WiGL. So they'll be there for you to explore and play with and break and run into errors as you see fit. All right, so let's get going. Let's do some introductions here. So first things first is, how do you even pronounce this? So the tech part of LaTeX was intended to be tech, with letters tau, epsilon, and chi from the Greek techni. It's sort of a source of humor in the LaTeX community of all these different pronunciations for LaTeX, and all of these I have heard either in person or in online spaces about how people pronounce this. Lamport has this to say about LaTeX. So one of the hardest things about LaTeX is deciding how to pronounce it. It's also one of the few things I'm not going to tell you about LaTeX, since pronunciation is best determined by usage, not fiat. Tech is usually pronounced tech, making LaTeX or LaTeX the logical choices, but language is not always logical, so LaTeX is also possible. For me, I will be using LaTeX. Generally, from what I've seen, people tend to pronounce this based on the first way they heard it or started using it. And for me, that was LaTeX, and that's how I will be pronouncing it going forward. All right, so we're going to talk about a little bit here is the main goals of the workshop is a general introduction. What the heck is LaTeX? What is it not? What's going on here? Relative to word processors that you might otherwise be familiar with, like Word, Google Docs, Pages. And I really would like to establish a foundation from which you can expand and explore uses of LaTeX on your own time, in your own work. So what we're going to do here, LaTeX is very learn as you go. You should never just sit down and read a book on how to use LaTeX. You should just sit down and use LaTeX. You should sit down and run into errors. Don't bother memorizing anything. Simply look up what is needed and necessary for the tasks that you're doing at any one time. We'll go over some examples of how you implement LaTeX using skeleton documents that you can then expand upon in your own time. And the time that you invest initially in LaTeX will be very well gotten back at later times. There is a learning curve with LaTeX, but once you get over that curve, you'll never look back. So at the conclusion of today's workshop, you should know how things are generally written in a basic LaTeX text document. You should know what are the basic elements and ingredients of LaTeX. At the end, you should have a base from which you can use these tools for your linguistics work, or if you're writing notes for class, and then have a foundation from which to expand if you choose to continue to use LaTeX in the future. All right, so what is it? Well, TeX was a computer program created in the 70s, intended for typesetting in academia. It was intended for printing typeset documents, especially in the domains of math and engineering. LaTeX is a document preparation system for TeX typesetting that was created by Leslie Lamport in the 80s. So LaTeX instructs an interpreter on your computer how to format documents using TeX that's underneath all of this. So LaTeX is sort of the user part interface. TeX is what's underneath. If you have any experience with markup languages like HTML, XML, or RTF, then LaTeX is going to seem very familiar to you. It's a programmable publishing features that behave similarly to markup languages. There's a lot of extensive typesetting and typography that goes on in the background of how things are laid out in a LaTeX document. And some of the things that this offers are automatic numbered and cross-referencing, typographically consistent tables and figures, page layouts and geometries, automatic bibliographies, which are especially nice. So these are some of the features that are offered by LaTeX. Linguistics is indeed one of the target audiences for LaTeX. In a lot of academic domains outside of linguistics, you'll see it used in math and physics and engineering. Anything that has to do with technical notation, diagrams, tree structures, math, things like that. LaTeX has those fields are the target audience for document preparation using LaTeX. Some philosophical situations here with LaTeX. It was designed with the intent of separating content from formatting. So what does that mean? What that means is that LaTeX is what you mean is what you get, as opposed to what you see is what you get. So what you see is what you get is like Word. For example, when you're typing in Word, you go ahead and typing, and you're seeing the document being made in real time as you're typing and putting things together. LaTeX is not that way. LaTeX is separating that content from the formatting, where you are supplying a semantics to commands, you are typing into an editor, and based on typographic principles, that is computed automatically. So you don't have to worry about the formatting while you're working on the content. They're two separate things. For example, if any of you is working on a long document in Word or Pages, and you like slightly adjust the size of an image or a figure, and it cascades and kind of ruins the entire document, working with LaTeX circumvents that because we've separated this content and formatting. So here it is at a glance, some features between these editors. What you see is what you get, like Word, Pages, Docs, things like that, and LaTeX. Document editing. Users need the same tool. So if I send you a doc file, there might be an issue of it cross-formatting, or if I send you Pages, Pages only works while using Pages. LaTeX can be written in any text editor. If I'm going to change format, what you see is what you get. Document needs to be checked for unwanted results. So like if I change like that size of an image, or I change the numbering of examples, I may have to do that manually. In LaTeX, I can just change the class of what I'm working with. Say if I want to move from a presentation to like an article, I can do so just by changing a command. The larger you get with your project, the more unstable what you see is what you get programs become. LaTeX can be broken up into smaller pieces and can handle and compile this information much faster and less taxing on a machine. Citation tools are built into LaTeX. For those of you that use programs like Zotero or any of those other bibliography management tools, there's a button there that says export to bib, and you can just upload that into your LaTeX file, and then everything's cited for you and everything's all right. LaTeX is highly compatible across editors and operating systems. This is in contrast to some closed system, some closed source, what you see is what you get editors. Neither of these are backwards compatible to a certain extent, which is a bummer, but that's all right. We can split our files for better management. And my favorite part is LaTeX is free and open source. So it's community driven with accessible documentation and resources. And that's not always the case with what you see is what you get. So there's at a glance some philosophical differences between the different editors. So let's go ahead and compare it with something that you might be familiar with. So here on the left, I have just a screenshot of working with Word. Here's a document that I made back in 2022, just a simple minimum working example. To get this similar output, this is how I type it up in LaTeX, is I tell it, hey, I'm building an article class. That's like opening a file here in Word. I give it a title. I tell it who the author is. I want to give it a date, possibly today's date. And then I begin the document. That's where I type in my hello world. So these two are equivalents. If I'm writing in Microsoft Word, it looks like this. If I'm writing in LaTeX, it looks like this. So here's a breakdown of what all those components mean. If I'm building a document class called an article, it's telling LaTeX, hey, we're going to be working on a simple article, like a paper. I'm going to give it a title. I'm going to tell it who the author is. I'm going to tell it the date. I'm going to begin the document. We're going to tell the document to have a title. We already gave it what information it needs. Now it's going to put that together. Here's the content, hello world, and then we end the document. I can do the same thing for a presentation. Instead of an article, it's called a beamer. We're not going to go over presentations here in this workshop, but this is what it would look like, is I have a different class as opposed to an article. It's called beamer. I begin the document. I begin a slide, and I give it some content. And that's what that looks like here. All right, so that's what the markup is going to be kind of looking like. That's what you can expect to run into when you're working with LaTeX. So let's take a look at a couple of minimum working examples. These are called MWEs. So this is how you read a LaTeX document, is I tell it what kind of class to have, and then I begin the content here. And this is about as minimal as you can get. And this gives me hello world. The anatomy of a document is made up of these components. First, I tell it what class to have. Here's an article, and I'm specifying my page size and my font size. Then I have all this stuff here, what's called the preamble, which maybe I'm using, I'm telling it who the author is or who the title is, or I'm defining some different parts that I want to use later in the text. Don't worry about these details right now. Just what the idea here is to understand the anatomy of a document. And then comes the content, where I begin the document proper and I do some stuff and then I end it. So this, for example, produces a document that looks like this. So hello is the name of my title. Daniel Quigley is the author. I'm giving it a date and I'm writing hello world. Bibliography management is handled in a separate file. That's called a .bib file. We'll take a closer look at this a bit later. But if you're going to export things to be compatible with your LaTeX document, say you're working on, say you want to cite an article and you're reading it from, say, Glossa, there is a button that you click that says export to bib or use in LaTeX, and this is what it gives you. We'll take a look at this later, but just to keep in mind, this is what that formatting looks like. And then in my actual text, I have different ways to cite. Now, this is especially useful, and we'll come back to this later, but these are what the commands look like. If I'm, I'm typing away, I'm talking about this, that, and the other thing, and I have to cite my source, I do /cite, and I put the name of what I'm citing in here, and this is what it gives me here. And I have different ways for this all to show, whether they're parenthetical citations, if I want to list all authors, or if I just want the year. This is all supported in my LaTeX document. As long as I have this in my bib file, I can go ahead and cite it, and then we're good to go. we'll come back to this and how to work with a bibliography at a later time. But this is just a sneak preview of what this looks like. All right, so let's do a simple example in Hello World. There are 3 ingredients that you need to get LaTeX working. You need a text distribution, you need a LaTeX editor, and then you need a compiler. Don't worry about all this. You and I can spend some time and get it set up for Windows or a Unix-based system or Mac OS. The easiest tool to use is called Overleaf, and that's what I'm going to encourage you to check out as we work through this workshop. Overleaf is an editor in the browser. You just go to overleaf.com, sign in with your email, and then you can go ahead and start making LaTeX documents as you go. A LaTeX editor is what you're actually using to interface to talk to a text distribution. Really, you could use any text editor, but there are some that are nicer than others. For example, I use Text Studio, but some people like to use TextMaker. And they need a compiler. So if I'm going to turn it into PDF LaTeX or ZLaTeX or LuaTeX, these are all just names about how they encode fonts, essentially. Defaulted, most compilers do PDF LaTeX. Overleaf is nice because it does all of them. If none of these things make any sense to you, don't worry about it. These are just the main ingredients that are working behind the scenes for when you're working with LaTeX. So what I use personally is I use MikTeX for Windows and MacTeX for Mac OS. You just go ahead and download them from the open source locations. I use Text Studio as my editor, and I use PDF LaTeX because it's already a part of Text Studio. So this is what I like to use. This is what I personally use. But I recommend using Overleaf. It's an all-in-one distribution editor and compiler. It's web-based, so you can log in on virtually anything. It's super useful for collaboration because you both can access it on a browser. You just need to sign up, so you don't need to install anything to your local machine. You just access it on a browser. And it can be accessed on mobile devices if you need to make quick edits, say on your phone or on a tablet device. So this is what I highly, highly recommend you work with, especially as we will go through this this workshop. Just go on over to overleaf.com, sign in, preferably with your school email. Oftentimes your university will have LaTeX resources for you. Usually they're hosted on Overleaf. So I highly recommend you check that out. So you go to overleaf.com, register in the top right, click create your first project, gives you a blank project, and then you can name it whatever you want. You click create, and then you are ready to go. That's all there is to it. So I'm gonna stop here for about 2 minutes. That's about as long as it takes to get going on your first LaTeX project. And I encourage you to kind of doodle away on that as we work through the workshop. Just go to overleaf.com, register, make the first project, and give it a name. Overleaf is additionally useful is that they have all kinds of tutorials. So if you have questions about how to do a particular task or how to format it correctly, more often than not, there's going to be a fairly detailed article walking you through how to do that. People like to upload their own templates and examples onto Overleaf. There are thousands and thousands of examples of homework templates or dissertation templates or presentation templates or poster templates. People upload them daily. Many universities, like I said, upload their official and non-official LaTeX templates. And where they upload those is Overleaf. All right. So let's take a look at what an overleaf project looks like. Many text editors will also look like this. If you end up getting, say, for example, Text Studio, it'll have a similar layout. So over here, this is where you're actually going to be typing and doing your editing. Every time you make edits, you can compile it so it makes your PDF over here. So this is what's going to look like. This is the output. Your files here on the left, this is where I'm going to save my bibliography file. This is where I'm going to save all my images if I want to have images in my documents. This is where I'm going to have my different tech files that I'm working on. And then if the particular project that I'm working on has different sections, like an introduction, background, methods, things like that in my document, that outline will be listed here for you to navigate. All right, so this is how you read overleaf. And here I have just in greater detail what I just said. The files is where the components of your project live. Outline is where the sections are. The editor is where you write the LaTeX code. And the PDF output shows you the results of your LaTeX code. All right, let's go back to the anatomy of a project. So first I'm going to give it a document class, probably an article. But it could be a poster, could be a presentation, could be a book. This section here between the document class and the content is called the preamble. That's where I put, different packages. Packages are like the settings that you have at the top bar in a Word document. And then you have the content where I actually write on my project, where I begin the document and end the document. So I have document class, preamble, content. So all three of those put together a LaTeX document. So here's an example of a minimum working example. I have a document class that's an article. This use package UTF-8 input enc, that's input encoding. That's just so that Unicode is supported. Sometimes different fonts, or if you want to type directly different characters that are non-Latin alphabet. It's good practice to always have this. This helps encode enforce that Unicode encoding. I put that in my preamble. I also put the title, I put the author, I put the date. All this is going to live in the preamble. And then in the content section, that's where I have my document proper. We're going to begin the document. I'm going to make the title now that I gave the different values for the title content. I'll have an introduction section, and then I'll end the document. Now I can put hello world in that introduction. I recompile, and I've done my first true LaTeX document. All right, how do we feel about this? Where are we at right now? How are people feeling about this? Everyone kind of follow along here. Yeah, the main point that I really want to stress here is that we need these three ingredients. We need the class, we need the preamble, and the content. And that's how we make our document.
Yeah, I think I'm following. I've used Overleaf before, but I've never sort of fully understood it in its
Okay,
totality. So I made a little new toy document and I played around with some stuff and I
good.
I added this use package UTF-8 as well. So
Yes, especially for linguists, it's super important to have that for proper encoding. All right, so that's a project right there. So now I want you to play around with this a little bit. So maybe you want to change your sentence to "Hello world, I'm a linguist learning LaTeX at WiGL 18," and then recompile it. Now, when we do that, to get this fancy looking LaTeX format, we got to do \LaTeX written in this way, or \LaTeX curly brackets. When we do that, backslash LaTeX will make it so there's no space after. Curly brackets preserves the space afterwards. Let's put the word and in there and try the ampersand and see what happens. Or change the S in linguist to a $sign and recompile and see what happens. What you should be seeing here is some weird things. First of all, the ampersand won't appear at all. Second of all, when you put in the $sign, your whole document sort of crashes. So what happens, it turns the rest of the following text into, becomes italicized, and you get red warnings if you're working in the editor. So what's going on here? If we take a look at what's going on, I have this backslash begin document, I have this backslash end, I have this backslash document class. These are called typesetting commands. Something written with a backslash, that's called a typesetting command. And the objects in the curly brackets, those are called arguments. LaTeX is powered by these commands. So if I want to do a certain task, if I want to put something into boldface or italicized, or if I want to, as you saw before, if I wanted to cite something, it's backslash something. That backslash is telling you, hey, we're doing a command, and some commands, they require an argument. These square brackets are optional arguments. Curly brackets tend to be required arguments. And then the issue that we saw with the ampersand or the $sign is because some characters already have a definition in LaTeX and they perform a certain function. So if I just use the $sign, LaTeX is expecting, hey, the content following this $sign has to be mathematics. Or if I use a percentage sign, LaTeX is going to think, oh, I want to comment these out and I don't want to use these in my code anymore. So if we want to use the $sign, then we got to use our favorite backslash again. So now the $sign will show up as we expect it. Or if I want to use the ampersand, I got to do backslash ampersand. Your backslash key is going to get a lot of use when you're working with LaTeX. All right. Let's take a quick check here about what's important for our LaTeX document. We have 3 parts. We have a class, we have a preamble, and we have content. All our LaTeX projects are written in tex files that get compiled into a PDF. And our bibliography information is going to be saved in a .bib file. LaTeX commands are written with the backslash, and they can have arguments. So that's what we've gone over so far. I hope right away you can see how this is quite different from other text editing software. You can see that we have a tremendous amount of control, and we got to pay attention to the commands that we're using. Document class is going to tell us, hey, are we working with Word or am I using PowerPoint? The preamble is essentially the settings and the top ribbon in Word, and the content is where we write our work. We have different files here that we got to work with. The tex file goes into a PDF, and commands are all in backslash and have arguments. So those are the main ingredients. The rest is just details. Okay.
I have
Yes.
a brief question.
Yes.
So the commands get a backslash before them, but so do like the escape sequences for special characters. It's both of them, right?
Yes. Yes.
Okay. Okay.
Yep.
I had to make. Thank you.
The backslash is essentially tagging whatever is following so that LaTeX knows to pay attention to it in a certain way.
Gotcha.
Okay. Let's take a look at some components or elements of LaTeX. All right, so the rest of the workshop here in the last 30 minutes is I want to go over LaTeX in general. What are some important things to keep an eye out? Like if I want to choose a font, if I want to change the text size, or how do I do tables and figures, things like that. So these are the main ingredients that we might want to be working with in our document. A default font is going to be Computer Modern, which I think is a fine font. It's not very pretty. but we can declare what font we want in the preamble. Say I want to use Times New Roman, for example, or if I want to use Palatino or Helvetica, I just declare that in the preamble. It's like, hey, I'm going to use this package, I'm going to use this toolbox, and it's going to tell me what font I'm going to use. And that's it. Some effects can be executed, again, using commands, backslash the command, and then the argument. So if I want to do boldface, it's text boldface, text BF. Italics, I use text IT. Small caps, text small caps, and so on. Here's a brief aside about what's good and bad practice. Suppose I'm working on my morphology paper and I want to do an interlinear gloss, and oftentimes those are written with small capitals. So when I'm doing my interlinear gloss, or I'm referring to a morpheme and it's giving me, I'm telling it to use the nominative, I might be tempted to use text small case nominative. Stands to reason to do so. However, that is bad practice. Instead, I want to define my own function, my own command, specifically for morphemes. So this is what that looks like. So instead of just using text small case nom, I want to define my own what's called a macro. So in the preamble, I'm going to say, hey, I'm going to build my own command. I'm going to name it something that I want. I'm going to do \m. That's going to be for M for morpheme. This new command, it's going to have one argument. And what it's going to do is it's going to make this text small case and then whatever I put in the argument. So now in my document, anytime I do \m, I know I'm talking about a morpheme. And there we go. Suppose I want to change font size, like say for title information, or if I really want to draw attention to something. These are all relative to the font size that I declare in the class. So if I'm font size 12 or 11 or 10, I think are the usual font sizes, then these get scaled according to that. So I have tiny text, script size, all the way up to huge. Now to answer Jay's question here, there are a couple of characters that are special characters. So the escape for that is backslash. So some protected characters are the $, percentage, ampersand, underscore, that little hat, backslash, and curly brackets. So if I want to use those literally in the document, I gotta backslash those. Now suppose I want to do sections and subsections in my document. They're named fairly intuitively. It's just backslash section, and I give the section a name. Or if I want to do a subsection, same thing. Backslash subsection name. And if I want to do a subsection, it's the same thing. Backslash subsection, and then I give that a name. So on that minimum working example that we saw at the beginning, I had section introduction. And I had introduction was the argument of the section command. All right, now before we start talking about lists, tables, figures, examples, all that good stuff, in general, they're all constructed in the same way. And these containers called environments. So remember at the start of this talk, we looked at begin document, end document as part of the content. Same thing here. We have a begin table, begin figure, and then we end table, end figure. This environment is a container for me to put those things in. So say I want to do a bulleted list. I do begin itemize, or if I wanted enumerated list, begin enumerate. How would you know that itemize and enumerate are the correct arguments for this? You wouldn't. You would just look it up. Don't bother memorizing everything that there is about LaTeX. When you run into a situation, just look it up. That's don't waste your time trying to memorize everything when the resources are there for you to explore. So within this environment, I do begin itemize. I have 1 item, 2 item, or this enumerated list, item, item. I can get fancy and I can nest those environments. So here I am nesting the itemize, nesting the enumerate. Tables, similarly, are built from environments. So this is what this code looks like for this table. Tables are extremely important. So we're going to walk through this one a little bit slowly. So the first thing we do is begin with a table environment. That's a container that handles positioning, captions, labeling, things like that. The tabular environment is where we actually build the table proper. And in this example, I'm specifying that we have a left justified, a centered, and a right justified columns. I could change this to be left, 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 or center, center, center. It could be however I care, or how many columns I'm interested in. This is just telling the table, hey, you should format in this way. All right, here's our first line of the table. I separate the columns with the ampersand. I don't need to do a backslash because I'm using this as LaTeX is expecting. And I end that line with 2 slashes. Maybe I want to put a horizontal line to separate the header from the rest of the table, and then I fill in the rest of the information. The last row here is not going to end with a double slash because that's just the last row of the table. It's not expecting any more rows. And so this gives me this table here. A nice package for tables is what's called book tabs, which gives us a very clean top rule, mid rule, and bottom rule for our tables. Again, how would you know this? Is you would look it up or run into the situation that say, hey, I want my tables to look nicer. Simply looking that up will give you this documentation. Tables take some getting used to, and they can be a bit of a pain. Luckily, there are some resources that are available to us. Tablesgenerator.com lets you just pick the number of rows and number of columns, and it'll auto-generate the table for you. If you have a CSV, LaTeX is compatible with just porting that directly into your document using this package that you put in your preamble, and you just name the table with this command. If you're working in Python or working in R, they can both export to LaTeX tables directly that you can just copy and paste into your LaTeX project. So try not to make tables as manually as possible. Instead, make your life easy and use one of these resources. For figures, there's a specific package that we got to use. It's called GraphicX or graphics. And the tool is called include graphics. So if I'm beginning a figure, here's my environment. I tell it, hey, we got to put a graphic here. So I'm going to include graphics. I might specify its size. And then I just tell it what the figure is or the image. So I have this PNG image of a wug. So I'm telling it to use this with this size in this environment. And here it is. If the image file is somewhere buried on your computer, LaTeX has to find it. So in the preamble, we just put the path to that image. If the image is in the same file as your LaTeX document, you don't need to worry about this. But if you keep all your files separately somewhere else on your computer, you have to tell LaTeX where to go to find it. Okay, tables and figures are nice and all, but we should caption them. Working with captions will automatically number the figures and tables for you according to order, chapter, section, and subsection. Anytime you change or remove a table, it will recalculate and auto count them so you don't have to do that manually. at the start of most of larger documents like your dissertation, for example, it will also automatically list these in the table of contents according to their chapter, section, and subsection. So what does that look like? So here's our table from before. Now I just included a caption command and I gave it an argument. So it already counts it and it gives a little caption. So here it is again with book tabs. I gave it a nicer table and you see how it's automatically numbering them. For figures, it's good practice to put the caption beneath the figure. For tables, you put it on top of the table. And you do the same thing. After your WUG, you do caption a WUG, and here we go. And here's a WUG facing the other way. Okay, so we got tables, we got figures, maybe we've got sections in our project. Now we want to label them. So labels are essentially hyperlinks in your document so that say I'm reading them, it will automatically link to where they're going. So say I have my WUG, I could put a label figure WUG2, and now I can reference it so I don't have to keep track of, okay, which number figure was this? I just tell it, hey, I'm labeling my WUG as WUG2, and then in my text, I just tell it to find figure WUG2. And that'll link up throughout the document. I can do that with sections, label a section, and it's the same principle with tables. Let's say, for example, here's my hyperlink for figure 3. It'll bring me right to figure 3. Here's my hyperlink for table 5. It'll bring me right to table 5. Some things to note and about labeling and cross-referencing is that this is accessible for machine accessibility purposes. Cross-referencing at this point in LaTeX development, these are very useful for machine accessibility purposes. A lot of work is being done on that currently for other kinds of figures and parts of a document. But where it stands right now, these are currently machine accessible. Label should come after the caption. It's good practice to use a little tilde for when you're using your text. So consider table something. The tilde keeps these things together so they don't get broken across lines. Labels should have a certain form to them. So if it's a table, I do tab, colon, name of the table. Or figure, I do fig, colon, name of the figure. It's not required, but it is standard practice. Interestingly, you do have to compile your document twice in order for this all to work. I don't know why. I don't know what's going on in the background for tech, but you do have to compile twice for these hyperlinks to work. Okay. Continuing on. You may have noticed that I had these empty brackets when we were creating table and figure environments. So what is this doing? Now, I mentioned that LaTeX is super useful for typographic purposes. That's because there are extremely complicated algorithms in the background to find the typesetting and typographically logical location for these objects. These are called floating objects because they float around to find a place. Do you ever read a book or a textbook and you say, hey, refer to figure such and that figure such and such is like on another page? Even though it might make sense to have it in that location. It's because it's a floating object that's going to its typographically destined location. That's what's going on here. We can break that if we force that object to be in the location that we want it to. You should do this after your project is complete. That's when you should fiddle with placement of floating objects. So if I want it to be here, I do a little H in those square brackets, or if I want it at the top of the page, I put T, bottom B, and so on. So those are called floating objects. I would put those arguments in the square brackets if I want to break the automatically calculated typography. Okay. The last thing that I really want to go over here is the bibliography. So how the bibliography works is that LaTeX needs to talk to what's called a .bib file. And this is where we put those lists of bibliography information. Once we tell LaTeX how to cite, it'll do the rest. So what does this look like? Initially, we can set this up and be kind of tricky because 3 things all need to be working in order for it all to happen. So I need a .bib file. LaTeX needs to talk to the bib file. And then the citations get placed. There's kind of a near religious war about what format to use for bibliographies. We're going to use examples like APA format. And then as you're going to look at more LaTeX examples, you might come across some confusing terms like what is BibTeX? What is Bieber? What is NatBib? What is Bibliotech? It's a bit of a nightmare to sort through, but they're all talking about bibliography management. For our purposes, we're going to use what's called Bieber with Bibliotech, and we're going to use tools from NatBib. Don't worry about these names. Just know that we have a couple of dials that we can turn depending on the style of bibliography we want to use. Might want to use APA, might want to use MLA, might want to use numeric. We can all specify that in our preamble. Some journals are very picky about which ones to use. I know Glossa is pretty picky about it. I know Language and Logic is super picky about it. And then there are some journals that don't care. So if you're going to submit to a journal, just check to see, hey, how do you want this formatted? So in the preamble, we use, hey, we got to use a package. We're going to use the Bibliotech package. We're going to specify we're using NatBib. Commands, we're going to use the APA style. And I'm going to tell it, hey, where's my bibliography? It's in a sources.bib file. So what I want you to do, say in Overleaf, you just create a new file, you name it sources.bib, and that's it. Then you have a bib file. That's all there is to it. Now the bib file is not a TeX file. It has its own organization, its own syntax, the whole bit. The bib file is simply a list of entries that looks like at type. So at is going to be like, this at type could be a book, it could be a journal, it could be an article, it could be a dissertation, doesn't matter. Then you give it a name, and you might have like the year of publication, the author, the title, all that good stuff. All these properties will have values, and that's how it gets reported in your bibliography. Don't worry about typing all this up manually. Just about every journal has a way when it asks you to cite it to export as a .bib, and let them take care of it for you. So here's an example. Say if I have this new 1984, this is what I'm going to reference it in my document when I use my cite commands. Here I've specified the author, the title, the journal, the year, volume, number, pages, address, and publisher. So this is an example element of my .bib file. And then at the end of my document, right before the end command, LaTeX needs to know to print the bibliography at all. So we do that by telling it to do it with this appropriately named command \print bibliography.
Daniel, what was the argument in the use package for this?
I did natbib is true, so I'm going to use natbib commands.
Okay.
I'm using the style APA, and then the argument is bibliotech.
Cool, thanks.
And then in my text itself, natbib has all these really flexible commands to give different kind of citation styles, different parenthetical styles, or if I want to cite all the authors in a work or just one author, or if I just want to specify, hey, see Newth, 1984, chapter 2, and then in here I could put the page number. But what's going on is we're using the cite command. I'm putting in my label, Newth 1984. So LaTeX knows to check my bib file to find the Newth 1984, and it will cite appropriately. Okay, so that's what I want to say about bibliographies. At the end of this presentation, and the last slide is an example of what the actual cited page looks like. But what the main parts that I want to talk about in this workshop were, what is a LaTeX distribution at all? What the editor and compiler are doing? What does the document structure look like? What is the anatomy of a text file? We have a document class, we have the preamble, and we have the content. The two important file types that I want you to be aware of right now are the .tex, where we do all our work, and the .bib, where we do our bibliography stuff. And what we looked at how to do titles and sections. We looked at font and styling text, special characters. We looked at how to do lists, how to do captions across referencing objects. And that's the content that I wanted to go over for this workshop here. The idea here is just to have all this stuff kind of floating somewhere in your brain and to have a presentation for you to kind of reference back if this is something you'd like to continue with going forward. There's a lot left to learn, but these are what I think are the core ingredients to get you started, so that moving forward is going to be less treacherous. The philosophy of LaTeX can be boiled down to this one sentence: good poets borrow, great poets steal. Whatever you're working on, steal everything you can from people who have already formatted things in LaTeX. This is the community for LaTeX is free and open source, so don't bother trying to build things up from the ground up. Just take what you can and give nothing back. The community of LaTeX users is very open and very excited about this philosophy. The CTAN database is the official documentation for LaTeX packages. It gives you information, how to use it, how they work. Stack Exchange is your friend. If you run into an issue, so has somebody else. Overleaf is your go-to text editor and repository for examples. And after this workshop on my GitHub, I will have these presentations and some toy examples for you to reference and play with. Things we didn't go over are things like installation. I didn't talk about getting this up and running, an editor up and running on Windows or on Linux or on Mac OS. For a dissertation, I didn't talk about how to split text files. So if I want chapter 1, 2, 3, and 4 in their own separate files, it's worth checking out how to integrate with R and Python, especially if you are using those tools. We didn't talk about like table of contents, list of tables, that kind of stuff, the index and dependencies. We didn't talk about presentations or posters. As you can see, there's a lot still to talk about here. But at the core of all of this is the material that we covered today. But I think that is more than enough for now. So thank you. And here's one example bibliography might look like.
Awesome. Thank you so much, Daniel. I think we've still got like a few minutes, so if anyone has any questions, you can feel free to put them in the chat or turn on your mic and ask. We will hang out for a little more. If anyone wants to be like, oh my God, what is this LaTeX thing? What have I been experiencing for the past 50 minutes?
It's a lot. There's a lot to go over, and it definitely is a lot at once. So it definitely takes some time to digest it, or forget all about it if you prefer.
Oh, thank you so much for that. That was actually really helpful for me as someone that is sort of like I've used I say LaTeX. I was told to say LaTeX. I I've used LaTeX, but mostly for group things where the other people know a lot more about it than I do, and they put things in there, and I'm like, oh, nice, a table has appeared. So this was helpful for me to sort of understand more of what is actually going on. If other folks don't have questions, I can ask questions. I was curious, like, what sort of motivated you to start using LaTeX?
So I like typography. I have a very deep interest in typography and like document design. And this was a way to kind of explore that. It was also easier to type up homework when I was doing like a lot of IPA symbols in linguistics, or if I was doing a lot of math when I was doing physics. This is the de facto document typesetter for working with those kind of things. And so I thought, okay, I'll do it. And then I never looked back.
Goodness, very nice. Yeah, I've had to use it before because a proceedings that I was accepted to required like the final submission to be in LaTeX.
Mhm.
And the folks I was working with were very sort of like browbeaten about it. They were like, all right, here we go, everyone. So, oh God. Uh, and then this semester I have one course that requires us to use it, but I think I'm definitely gonna go back and like look at this, especially for like now having done a full manuscript like in just a regular like text editor. Like I can see the appeal. I definitely can. Like so when it's like 30 pages of text and like 10 figures and it just like the formatting just goes crazy and you have like 60 sources and you need to
Yep.
I had to do the thing where I had to go through and make sure that all of the things that were cited in the text were in the bibliography and all the things that were in the bibliography were in the text, and that was such a pain in my butt. So
Yeah, life is short, so this does it for you.
but yeah, I will open the floor.
Now, like I mentioned before, I also put this up on the GitHub as well, where I kind of walk through the different tools specifically for linguistics. So like how to do like IPA, for example, or vowel charts. I have how to do like phonological rules. A lot of this is a bit more advanced. All this is built on like building your own commands. It's really building your own commands, the workshop. But this is more linguistic specific. But I also have this on the as a resource for people to reference, like how to draw trees, for example, things like this.
Okay.
Trees with different kinds of movement,
Oh wow.
or how to typeset semantics.
My goodness.
So
That's
this will
yeah.
all be made available as well.
Thank you so much for putting this together and also for any folks who didn't catch it. This is being recorded and this will be posted. I don't think we've talked about exactly where, but um we'll let you all know where it ends up being posted, so you will be able to come back and review it. But yeah, thank you so much, Daniel.
All right.
I will stop the recording. I can figure out how I practiced this last night. Here we go.